Hi, I'm currently doing Paul McWhorter's Pico W lessons and I'm up to lesson number 55 and he wanted us to create a dynamic rainbow. Now I've done all sorts of things like this before, so I thought I wanted to see if I could do something different. I've already filled up the screen, starting from the top going to the bottom, from the side, starting from the corner and doing various colours. But this time what I wanted to do was I wanted to start at that top pixel, work my way all the way around, changing it to red to start with, and then going down, 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 up, up, up. And then when I get up to there, I will start again on 1 pixel in and do it, and then do it so the screen fills up gradually in the first colour, and I'm repeating it for all the colours of the rainbow. And then what I wanted to do was I wanted to start up there and go through the colours of the rainbow, so that could be red, orange, yellow, green, blue, indigo, violet, and go all the way around. And also I could change how many reds I wanted and how many on, like that. Now that isn't as easy as you would think it was. Now you could have a big array of all the pixels, but it's 32 by 32, which would take up an awful lot of room. Or you could do it with a function and calculate what the colour is, but that would actually be quite difficult. I tried it. It is quite difficult to work out where you next want to go. So what I decided was the best thing would be to step through it, because you're going do 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 do, and as you're doing it, you know that when you get to the end, you just want to go down, and then you go back, and then you go up. And I thought this would be a perfect thing to do with a generator. Now I didn't actually know, I've never used a generator in Anger before, and I think of a generator as being a function that can remember where it was, and it also doesn't use the space that an array would use. So I will just show a couple of examples of generators. We will start with my first program. Now this is just a function, and what it's meant to do is it's meant to start from 0 and add 1 and add 1 and add 1. So we'll run it. Right, it says 0. Now what happens if you run that lots of times? You'd think it would say 0, 1, 2, 3, 4. But no, of course it doesn't, because the function has no memory. So we'll have a look at this. Now this, it looks very similar if you look at that, and all I've done is change the return to a yield. So that is now a generator, and you have to do it a bit differently. You have to set it up as an object as your generator, and then you just go next, 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 and hopefully it would work. So we'll try running it. Right, 0. That works the same as the function. But we'll try doing lots of nexts. And that is exactly what you want, because what it does is it goes, when you go next infinite, it starts off and it goes down until it hits a yield statement. It gives it back to where it was called from there, and it remembers where it was. So next time round it comes in, adds 1 to none, goes back up there, and says it's 1, 2, 3, 4, 5, which is pretty cool. Now that would go on forever. I mean, you could, which is why I called that object infinite, because you could just go on and on and on. Now this is another one. This is a function, back to a function, which you're just squaring a number. You've got the numbers in the range of 0 to 4, and you're returning the square of it. So we'll run that. Yep. Try running again. Nope, as before, it has no memory. So we'll look at what it looks like in a function. So I'm just going to be changing that return to a yield. So this is called finite because you're only getting the squares of the numbers of 0 to 4 inclusive. So we'll try running that as before, 0. But this time run that, and it remembers. It goes in there with 0, and it says, oh, I'll yield 0 squared, which is 0. I will hang on there until you do another next, and then it goes 1, 4, 9. Right, what happens if we put like that? Oh, when it runs out, it says, I don't have any more, because it's giving all the values back to you, and then after 16 it doesn't have any. So that's great. So you can cater for that. You can either catch the error or make sure it doesn't happen. Then this is another variation. You can have more than one yield in your generator. So we'll just run that. It goes 0. Let's copy. Right, so what that does is it goes in, num equals 0, it yields it, which is 0, then it hangs there until you do another next finite, and then it yields that. And then when it goes in again, it's num equals 1, and then it prints out, I can yield this too. But it will still run out. So if you put in, I don't know how many more, that definitely will go wrong, I'm sure. And again, stop iteration. That's great. That is great. There are various things you can do with a generator. You can actually go, we'll go back into this one. If we put in a finite dot, whoops, close, and then try and print anything. Sorry. Right, it does 1, it does 2, and then, oh yes, no it doesn't, it does 0, and then it yields that I can yield this to, then it does 1, and there it is, and then if you go finite.close, that is just saying I'm not going to yield any more values. So when you try and do that, then it will give you an error. But if you want to start again, for example, you could just copy that line and create another object of the same thing. And as you can see, it goes 0, I can yield this to 1, you close it, and in fact you don't need to close it there, you could just go finite equals that without the close, and it would start again, and it starts again on naught. I mean, this is just a vague demonstration of what generators can do. Right. You can also, this is a list comprehension. Laurie and Keith are very into list comprehensions. So that is just, you put in num squared LC. Now, you take the number from 0 to 4 inclusive, and you square it and you put it into a list. I just show you what it does. There. List comprehension. It just creates you a list, and then I print it out. Now you can do the same thing with a generator comprehension. All you have to do is change those square brackets around there to round brackets. Here we go. So that is exactly the same, only it doesn't return them all to you at once, it returns them gradually. So if we do that, if you just print, like in the previous example, you print, no, was that the right one? Yes, you just print the num squared LC. If you're printing just num squared GC, it is printing that it's a generator object. But then the next time round, it actually prints the, no, sorry, then it prints next of the things. So then it will step through all the things. So if we repeat that, and again, when it's run out of values, it will say stop iteration. You can do various other things, and you can get really complicated with generators. But that is just what I was wanting to show you that I was doing. So this is the actual program. I could run it to prove, probably getting fed up with what everything's happening, so I will run this program and see what happens. So that is gradually filling it up. There. Now, using my, oh, I'll make that bigger. Don't need to look at that thing any longer. Right, this is just a program I've written before when you're creating all the colours there and setting the brightness and everything. And then for all the colours in the rainbow, I'm just putting them in an array. So this is the bit. This is just when I'm going through and I've worked out how many pixels there are, which is 32 squared, and I'm just going XY is next to my pixel, and then displaying that actual pixel. And how it's doing it is going into this generator, which you can see why it's quite complicated. So what it's doing first is it's going along the top. In fact, I will get my thing back. It's going along the top of the thing, which is what that for X in range there is, and it just yields, remembers where it was, and then when it gets to there, it goes into the next for loop, which takes it down there and yielding all the time, and then it goes along there, and then along there, and then it goes into the next ring. So it starts there and does the same thing, and it's don't really need to explain everything. It just really works, and it's a much better way to step through and do it gradually, rather than thinking, oh, what's that one, kind of thing. So I just thought people might be interested in generators. Probably no one can understand it, not through their stupidity, through my bad video.